అవి ఎట్లా వేస్తారు నాకు తెలియదు. నీకు తిననే వేసుకొని చదవన్నా.
Hello everyone. Let's wait for a couple of more minutes and then we will start today's session. Okay, it's 5:58 and I think we can start today's session. So let me introduce myself. My name is Arpit Bal and I'm a PhD scholar at Department of Electrical Engineering, IIT Bombay. So currently I'm pursuing EHT and I'm a PMRF scholar and this is so I welcome you all to Digital System Design Week 1 live session. So these live sessions are supposed to be of tutorial form. So we will be solving some problems, some previous year problems. And so if you have any queries related to the problems that we are going to solve in this session, so please let me know. It is supposed to be interactive uh, and we'll be solving the problems together. So I'll suggest you to have a pen and paper ready with you so that the moment I start uh, solving the questions, you solve it along with me. Okay. And if you have any queries regarding the live sessions that are going to be conducted in the subsequent weeks, so you can raise the queries in the Q&A forum of SWAYAM platform. Okay. And the recording of these sessions will be available. So you can. So I'll be uploading the recorded sessions here. And the slides for the same will also be shared with you by the NPTEL team. Okay. With that brief introduction, so we can start today's session. Okay, so it's already 6. Okay. Okay, so this is a previous year assignment and we'll be solving these questions. So which of the following best describes a digital signal? Okay, so out of these options, we need to choose the most appropriate one. So if you can see, so the digital signal is nothing but it is both continuous, discontinuous in time as well as amplitude. So it is discrete and discontinuous in nature. So this is the correct option. Okay. I mean, it is definitely not continuous and smooth in values and time. So option 1 is wrong. Option 3 is wrong because it is not a combination of continuous values forming numbers. And option 4 is wrong because it is not an analog representation of digits, right? So, so when we say it is an analog signal, it is basically a continuous form of signal, and it is not discretized in values, right? So yeah, option B is the correct answer for question number 1. Okay. Moving to question number 2, what are the two key steps involved in converting an analog signal into digital signal? Okay. So let us say I have an analog signal which looks like this. Okay. Let me say that this is a sine omega t. Okay. And this axis is t. Okay. So to convert it into digital signal, first I need to discretize it in time domain. Okay. I need to take discrete samples in time. Okay. Then after taking discrete samples in time, I also need to take discrete samples in amplitude. Okay. Okay. The process of discretization in time is called as sampling. And the process of discretization in amplitude is called as quantization. Okay. Sampling means, so the signal exists at particular samples, or signal exists at particular time period and not uh, continuously throughout all the time instance. Okay. And quantization means it is the signal is allowed to occupy only some particular set of values, right? So the answer to question number 2 is discretization in time and discretization of values. Okay. So option 3 is correct. Okay. Moving to the next question. So what is the primary difference between positional and non-positional number system? Okay. So basically positional number system is the one where you have uh, where we assign values to the particular symbols based on what position they occupy. Let's say binary. Okay. So I have 1, 2, 4, 8. Okay. So if I'm assuming that let's say I'm writing 1010. Okay. So it means, so 1 represents that I will have 1 into 2 to the power, sorry, into 2 plus 1 into 8. Okay. So 1010 represents 10. So the uh, value associated with each place uh, actually has a weight related to its position, and that's why it is called as positional number system. Whereas on the other hand, when we are talking about non-positional systems, we have fixed values that are assigned to the symbols, that are assigned to the particular symbols. So positional systems assign values to symbols based on their position, while non-positional system assign fixed values to the symbols. Option B is correct. Okay. Moving to the next question. What is the decimal equivalent of the binary number 110 dot 011? Okay. So I have, so let me just write it, 110 dot 011. Okay. To the left side of decimal, so I'll have 2 to the power 0. Okay. And this will be 2 to the power 1, and this will be 2 to the power. Okay. But to the right side of 0, I will have 2 to the power minus 1 plus 2 to the power minus 2 plus 2 to the power minus 3. Okay. If I sum it up, I will have 4 plus 2 plus 0 plus 0 plus 1 by 4 plus 2 to the power minus 3 is 1 by 8. So I have 6 plus 0.125 plus 0. So I have 6 plus 0.375. The answer is 6.375. Okay. Is this part clear?
Yes.
Okay. Okay. So moving on to the next question. So in this question, we are supposed to find out what is the binary equivalent of the decimal number 45. Okay. So in the previous question, we were supposed to figure out the decimal equivalent. In this one, we need to figure out what is the binary equivalent of number 45. Okay. So whenever we are supposed to figure out the binary equivalent of a number, you take the number, you go on dividing it with 2. Okay. And you see what is the remainder each time you divide it with 2. Okay. So if I divide 45 with 2, so I will have 22 and the remainder will be 1. Again, I will divide it. I'll have 11, remainder will be 0. I'll divide it again. I'll have 5, remainder will be 1. I'll have 2, remainder will be 1. I'll have 2, remainder will be 0. At the end, I'll have a 1. Okay. So then to find out what is the binary equivalent, I'll take the digits in the reverse order. Okay. So my final answer is the binary equivalent of 45 is 101101. Okay. Is that clear? So 101101 is, did I miss anything? No. Okay. So this is option A. Okay. Is this clear?
Yes, sir.
Okay. So moving on to the next question. So we are given a binary number 1001 1110, and we are supposed to figure out what is the hexadecimal equivalent. Okay. In this case, what we need to do is you club. Okay. So the hexadecimal number system is basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and instead of 10 we have A, B, C, D, E, F. Okay. So these are the complete symbol list that are used in the hexadecimal number system. And why is it hexadecimal? The reason is total number of symbols, you can see it is 16. Okay. And that's why the name. Fine. So I have the binary number 1001 1110, and I need to find out what is the hex equivalent of this number. So what I will do is I'll club 4 bits at a time. Okay, because 4 bits are needed to uh, uh, like represent total 16 symbols, right? So what is 1110 in decimal? So 1110 is nothing but 12, 14, right? So what is the 14th number in this element? Sorry, what is the 15th number in this element? Because first one is 0, the 15th one is D. Sorry, 15th one is E. Okay, so this is nothing but element E. Next, 1001. 1001 means it is 9. right? And till 9, the symbols in decimal and hexadecimal are same. So I'll write it as 9E. Okay. And whenever we are representing something in hexadecimal, we represent it in this format 0x and the number that we have. Okay. So 0x9E is the correct representation of this binary number. Is this part clear?
Yes, sir.
Okay. Does anyone have any question for question number 6? Is there any query?
No.
Okay. Okay. So moving on to the next question. Okay. So in the next question, we are supposed to perform binary subtraction of these two given numbers, 1101 and 100. Okay. Okay. And we need to mention what is the result. Okay. So if I subtract 1, 0, it is 1. This is 0. This is 0. This is 1. Okay. So this is the answer. So 1001 option. Okay. Okay. So moving on to the next question. When does overflow occur in addition? Okay. So what is the overflow condition basically? So this condition arises when you have, why we represent 0x9e instead of 9e. Yeah, so this is basically a form of representation that is used. So this is by convention we write it as 0x to represent hexadecimal. Otherwise, how to distinguish it from a number or from an algebraic expression, let us say. Okay, is that clear?
Yeah.
Okay. Okay. So when does overflow occur in addition? So this overflow condition occurs when the signs of both the operands are same, but the result has an opposite sign. Okay. So this can never happen, right? So assume that you are adding two numbers. Okay. Let's say +3 and +2. Okay. And I'm representing it in 3 bits. But the end result that I get is -1. That can never happen, right? Okay. Let me just give a small example. So I took +3, so 0, 1, 1, and +2, that is 0, 1, 0. If I add both of them, okay, so let us say this represents the sign bit, okay, and I am using a 3-bit notation. So what will happen? So this goes as 1, this is 1, 1, 0, and this is 1. Okay, so the result that we obtain has a 1 in the sign bit, okay, which is different from the sign of the two numbers that we have added, right? Okay, so this implies that this is an overflow condition. Okay, because the result of two positive numbers addition cannot be negative, correct? So yeah, so this is called as overflow condition. Okay, the other three options are wrong because when the signs of both operands are different, I mean this is not an overflow condition, and when the result is always positive is also not an overflow condition. And the fourth option says overflow can never occur during addition, which is wrong because I have given an example where there is an overflow condition. Okay. Okay, moving on to the next question. What happens when converting a 4-bit number to an 8-bit number using sign extension? Okay, so suppose I have a 4-bit number and I want to represent it in 8-bit notation. Okay, so what should be done? Can someone try to answer this? You can B option. Okay, is there any other solution to this? Okay, so when this question is being discussed, so is it true for both representation? So can I do the same thing for signed magnitude representation as well as 2's complement representation, or only 2's complement? Yeah, correct. Okay, so this is only applicable for the 2's complement representation. The most significant bit is extended to fill the extra bits. Okay, so option B is correct. So suppose I have a number, let's say, okay, let me have 1 here. So let's say it is 1001. Okay, this is a 4-bit number and I want to make it an 8-bit number. So what I will do is I'll copy the MSB in the remaining bits. Okay, I'll have 1001 and I'll have 4 more ones, 1, 1, 1 and 1. Okay, so this is my 4-bit representation and this is my 8-bit representation. So whatever is the sign bit, you copy it 4 times. Okay, to do the sign extension. Is that clear? Okay, so moving on to the 10th question. So assume an 8-bit number and an offset of 127. Represent the value minus 45 in sign magnitude, 1's complement, 2's complement and offset notation in the same order. Okay, I think 45 we have already done. Yeah, 45 we have already done, and the okay, so let me start. Okay, so if the number is plus 45, I will be representing it in this way. So I'll have my binary representation as 101101. Is that clear? Okay, so now I have to represent this number in sign magnitude form, 1's complement form, 2's complement form and offset notation form. Okay, so to represent it in sign magnitude form, what I need to do is, okay, first I need to make it 8-bit. So I have a total 4 plus 2, 6 bits. So I need to add 2 more bits. So 00101101. So this is the representation for 45. Okay, in sign magnitude form. So what I will do is I'll just change the MSB to represent minus 45. So sign magnitude minus 45 will be 10101101. Okay. Next thing is in 1's complement form. In 1's complement form, I need to invert all the bits of 45. So I'll be inverting these bits. So I'll have 1101 0010. This is my 1's complement representation. Now coming to the 2's complement representation, I just need to add plus 1 to the 1's complement representation and I'll have my 2's complement representation. Okay. Okay. So what is the last part? It is the offset notation that we need to represent. So for representing it in offset notation, what we need to do is we have minus 45. We need to add the offset that is given to us as 127. Okay. So what will the result be? 82, right? So we basically need to represent 82 in binary form. Okay. So what is 82 in binary? Please try to figure it out. Okay, I'll wait for 2 minutes. Try to figure out the binary equivalent of 82 and put it in the chat box. Yeah, okay. So both the answers are correct. So basically, to get the binary equivalent, I need to divide by 2. So I'll have 41. This one is 20. Okay. So the representation will be 10100010. Okay. So these are total 7 bits. I need to make it 8 bit. So I'll write it as 01010010. Okay. So in this order, so what is the correct option out of A, B, C, D? Yeah, option A is correct. Okay. Is this clear? Is there any query in question number 10?
No, sir.
Okay. So we can move to the next question. Okay. So in the next question, we are supposed to find out what is the minimum number of bits required to represent the decimal minus 352 in 2's complement. Okay. So there is a shortcut to it, but let me go through the normal procedure. So what I will do is I'll try to find out the minimum number of bits required to represent 352. Okay. Okay. So what is the number of bits needed to represent 352? It is total 9 bits. Okay. But to represent minus 352, okay, because if you see that we do not have a sign associated with this number, so we are not putting a 0 in front of it. But to represent minus 352, we will need to put a sign, that is 1 in front of it, be it 2's complement form or be it your sign magnitude form. Okay, negative number, to represent that, I need to have a sign associated with it. Right. So the total number of bits needed will be 1 plus 9, that is 10 bits. Okay. Okay. So moving on to the next question. What is the hexadecimal representation of the sum of 3f216 plus this complete sequence that is given to you? Okay. So if I have to do such kind of addition, the first thing that I will do is I need to convert it into a common uh, representation. Either I need to convert it into decimal, or I need to convert this one into hexadecimal based on what output I need. Okay. So here I can see the output options are given as hexadecimal representation. So what the simplest thing that I can do is I can convert this entire sequence into hexadecimal. Okay. So first let me group them into group of 4. So I have 4 bits here, then I have 4 bits here, I have 4 bits here, 4 bits here, and 4 bits here. Okay. So 0 1 0 1. So what is 0 1 0 1 in binary? In decimal, it is nothing but 5, right? And because 5 is same in both decimal as well as hexadecimal, so I'll represent it as 5 itself. Okay. What is the next sequence? That is 1011. What does 1011 stand for? So it is in hexadecimal, right? So 1011 is nothing but 13. It means I need to find out what is the 14th symbol. So if you remember, the 14th symbol is nothing but B. Wait, sorry. 1011 is 11, not 14. 1011 is 11. So I have 8 plus 2 plus 1, right? Is my screen visible?
Yes, sir.
Okay. Yeah. Sorry. 1011 is 11. Right. So 11 means the 12th symbol, that is basically B. Correct. So I will have this one as B. And what is 1110? So 1110 means 14. 14 means the 15th symbol, and 15th symbol is E. Correct. And next is 0110. So 0110 means 4 plus 2, that is 6. Okay. And 1101. So 1101 means 8 plus 4 plus 1, that is 13. So 13 is your D. Okay. So now you are supposed to add these two numbers, D6 EB 5 plus 3F2. Okay. So these are the two numbers that you are supposed to add. So the rule that we follow is, so whenever there is a carry, we carry 1 here to the next place. Okay. And the remaining goes to this position. Okay. Let us see how to do this. So 5 plus 2 is 7, and 7 in hexadecimal is also 7, then B plus F. Okay, so what is B plus F? Yeah, so B was 11 plus F was 15, right? So I'll have 16, 26, correct? So if I write 6 here, so what I can do is I can actually carry one bit. If I carry one bit, what will I be left with? I'll be left with 10. Okay, and what is the representation for 10 in hexadecimal? That is A. Okay, A with one carry. Okay, so what is the next symbol? E plus 4. What is E plus 4? E is basically the number 14 plus 4, that is 18. If I carry one bit, then I will subtract minus 16 and I will be left with 2. So 1 is carried here. Okay, then 1 plus 6 is nothing but 7. Okay, and D comes as it is. So my final answer is D7, 2A7. Okay, and because it is hexadecimal, I'll use this notation: 0x D7 2A7. Is this clear?
Yes.
Does anyone have any doubt? Okay, so let me pause here for a minute. So if anyone has any query, please let me know for this particular question. If not, then we will proceed with the remaining questions. Okay, so you can unmute yourself if you have any query, or you can please explain the addition of B and F. Okay, yeah, sure. Okay, so this B and F addition. So what I did is, so to simplify things, what you can do is, so the first step is, so what is the value of B and F? Okay, so B is nothing but 11. Okay, and F is nothing but 15, right? So you add both of them. So if I add both of them, I have output as 26, correct? In hexadecimal number system, whenever there is a carry, so let's say I'm writing 10. Okay, so the place value is nothing but 16 in this place, because it is 16 to the power 1, 16 to the power 0. Correct? So whenever there will be a carry of 1, it means, so I'll be subtracting 16 from whatever number is present, and the remainder is going to go here. Okay, that's what I have done here. Is that clear? Okay, so another method is, you could have just changed 3F2 to the binary representation. Okay, added it conveniently, and then converted it back to hexadecimal representation. But I mean, that is like converting 2 or 3 times, right? So I found this method convenient, so that's why I went for it. But it's up to you how you would like to do this summation. Okay, so the next question is, what is the decimal number represented by the BCD code, this particular given code? Okay, so whenever we are doing a BCD to decimal conversion, basically you club 4 bits and you directly convert those 4 bits to your required numbers. Okay, so instead of I assigning the positional value to each and every bit, I just club the bits and figure out what is the decimal equivalent. So 4 bits, 4 bits here, 4 bits here, 4 bits here, 4 bits here. Okay, so 4 bits here, this is 1001, so this is nothing but 9. Then I'll put the decimal place here. Next I have 0101. 0101 is nothing but 5. 1001, this is again 9. Then I have 0100, this is 4. 0110, this is 4 plus 2, 6. Okay, so the answer is 6495.9. This is option. Okay, so question 12, the answer is 0x D7 to A7. So option 3.
Sir, again, sir, BCD code. What is BCD code?
Yeah, so BCD is nothing but binary coded decimal. So what you need to do is like, so if you have noticed 7 segment display, so you have like um, you have each segment representing 0 to 9, correct? I mean, even in some cases it goes to 0 to F, correct? So similarly, BCD is you just club 4 bits together and directly convert it into decimal. Okay, so
Okay, sir. Okay.
whatever binary number is given, you can just directly convert it into decimal. That will be the BCD code. So let us say I have some number 0110 0001. Okay, in binary, what will be the answer? Sorry, in decimal, what will be the answer if this is a binary number? Okay, basically you will have to do 64 plus 32 plus 1. Okay, can we represent BCD in A, B, C, D, E, F? No, that was an example for hexadecimal, not hexadecimal. Yeah, I mean, if you want to show it in the 7 segment display. Okay, so this actually comes as 97 if I have to assume that this is a binary number. But if I have to assume that this is a BCD number, what I will do is I'll just pick 4 bits, okay, and then convert it into decimal. So this will be 1 and this will be 6. So this will be 61 in decimal if it is a binary coded number. BCD, sorry. Okay, is that clear? The difference between a BCD and a binary number?
Yes, sir.
Okay. Okay, so moving on to question number 14. So question number 14, convert 3A7 uh, hex to binary. Okay, so hex you can also write it as 0x3A7, or you can just mention it like this. Okay, so we have already done similar examples, so I want you to 1101 in BCD. Yeah, okay, I'll get back to it. So if you already have this number, so 3A716 to binary, and you are supposed to subtract um this particular given sequence from the binary equivalent of 3A716 and then convert the resulting binary back to hexadecimal. Okay, so in each of the step, I want you guys to try it out and let me know the answer. Okay, so for first the first bit 1. So try to convert 3A760 into binary. Zero, zero. Okay, let's wait for some other answer. Okay, so first, okay, let me first answer the query. So if there is 1101 in BCD, okay, so 1101 will not be a valid code in BCD. So the reason is BCD code, you take it from 0 to 9 as digits. So if you remember, so whenever we have K-map, what we used to do is any number that was above 9 in BCD till 16, we used to take it as cross cross. Okay, so basically I have two digits present here. Okay, this can occupy 0 to 9 and this can occupy 0 to 9. Okay, and I do not have an option for anything above that. So I can't have 1101. That is invalid. Okay, so let's say I have 3A760. Okay, so I'll need 4 bits to represent this, 4 to represent this, and 4 to represent this. So 7 is nothing but 111. A is actually binary. In decimal it is 10. So I'll have 1 0 1 0, and 3 is 0 0 1 1. Okay, then what I need to do is I need to subtract this value from the binary equivalent of 3A7. So 0 0 1 1 1 0 1 0 0 1 1, and I'll subtract 1 1 1 0 0 1 1 0 1 1, and I'll just open zeros. Should be 0 0 0 0 0 0. I'll have a 1 here, so I'll go to 0. Okay, so at the end of, so this is stage 1, this is stage 2, and in stage 3 I need to convert the resulting binary back to hexadecimal. So club 4 bits. Okay, so this is 0, this is 4, this is 0. So I'll have 40 60. Is this clear? So everyone is getting 40 16. Okay, the final answer is 40. Is that clear?
Yes, sir.
Okay. 0 minus 1 equals 1. Yeah, this is basically okay. So This is not 0 minus 1, so I have borrowed 1 from the next digit. So what is 1 0 minus 1? Okay, basically you borrow 1 from the left hand side and you do the subtraction. So this will be 1, right? Okay. So if you still doubt me, so what you can do is you can just convert it into decimal. In decimal it is 2, this is 1. If I subtract both of them, this is 1. Okay, basically this one comes here as a carry. Is that clear? Okay. Yeah. So moving on to the next question. Okay. So what is the 2's complement representation of the decimal number minus 29 in an 8-bit? Okay. So try out this one and type your answers on the chat. Okay. So we have already done similar examples. So what you can do is first write down what is 29 in the option 3. Okay, let me see. So first I need to figure out what is the binary representation of 29. Okay, so if I have 2, then I'll be having, this is 14, reminder 1, this is 2, 7, reminder 0, reminder 1, 1, 1, so I'll have 1, 0. Did I miss something? Oh, sorry, this is 1. Okay, so it will be 1, 1, 1, 0, 1. Okay, so this is the decimal representation of 29. Okay, and we need to represent it in 8 bits. So how many bits do I have? I have 4 bits plus 1, 5 bits. So I just append 3 more zeros, and now I need to convert it into minus 29. Okay, so what I will do is I'll take the ones complement. The ones complement is just inverting the bits. Okay, and the 2's complement is just adding plus 1. So I have 1, 1, 1, 0, 0, 0, 1. Okay, so which option is that one? 1, 1, 0, 0, 1, 1. So this is option C. Okay, yeah, so many people have given the correct answer to this question. Okay, so that brings us to the end of today's live session. So yeah, so if anyone has any query related to whatever we have covered today, you can ask it now, or you can ask it on the forum as well. And this session was recorded, and the recordings will be available on the YouTube channel. I have shared the link, and even the solution to the problem set will also be available. So the NPTEL team will share the this particular slide that I have annotated right now. Okay. And yeah, so next week we'll meet at the same time, 6 p.m. So every Tuesday, 6 p.m. we'll be having our live sessions. Okay. Okay, so that's all. So if there are any queries, please let me know. Else we will wrap up today's session. Thank you.
Excuse me, sir.
Yeah.
Sir, when you represented 29 in 8-bit binary,
Yeah.
the MSB, it should be 1, right, sir, for minus
Yes. So, but in this case, what I have done is I have represented plus 29 first.
Okay.
Okay. So after representing the plus 29 in binary, then I took the ones complement of this number.
Okay.
Okay. And then you take the twos complement by adding a plus 1. Okay. Then it becomes the 8-bit representation of minus 29.
So there is no need to take the MSB as 1 for minus 29.
No, the MSB is 1 for minus 29. So, okay,
Okay.
when you are finding out the twos complement representation of minus 29, okay, so start by taking the number as plus 29 and then you proceed to take the twos complement.
Okay, sir. Okay.
Okay, yeah,
Thank you, sir.
yes. Okay, are there any further queries? If anyone has, then please feel free to ask.
No, sir.
Okay, okay then, thanks. So we will wrap up today's session and the recording will be available with you. Okay.